Modern three-phase motors are the workhorses of industry. They're extremely reliable and robust, but they are still prone to failure if they're not correctly installed or overloaded. Here we can see one whole phase completely burnt out. Let's look at testing them in situ. Firstly, rotate the shaft, do an external check on the body of the motor, make sure there's no signs of overheating, yellowing or burning of the paint. Then you can remove the cover and inspect internally. Here, any damage to the insulation caused by overheating will be noticeable by the smell. So it's always worth to check first before you start doing anything. Any clearly burnt out motors will be instantly obvious. Next thing we need to do is remove any incoming feeds to the motor, any internal crossovers to configure it for star or delta, so that we're left with nothing but the three windings connected to their junction box, with all of the terminals tightened so that we get good conduction for the test. Don't forget to carefully record where all of the wires went before you start stripping them out. A photograph or a little hand sketch is always useful, and make sure you've got all the labels in place on all of the wires that are removed, both before you take them out and actually after you pass them through the grommet. They have a tendency to get ripped off as you go. Make sure you've checked the condition of the fan at the rear of the motor. They do have a tendency to get damaged. If any material gets ejected and thrown into them, they can break easily, and that will cause overheating. So we're going to test this motor with the Megger MIT230. Covers a range of 250 to 1000 kilovolts on the mega ohm range, and can also test for normal resistance and continuity. Very useful, lightweight, easy to use piece of kit. Check your leads are free of any damage or tears in the insulation and connect them to the back of the unit, observing the polarity. Then with this unit, as it doesn't have a zero function, we're going to join the two leads together and actually measure the resistance of the leads to establish a baseline in case we need to check our figures later. Here we'll carry out a slightly more exhaustive test, but what you need to measure is the winding resistance between U1 and U2, V1 and V2, W1 and W2. They are the three main windings of the motor, which we need to check that the resistance is all the same. Make sure your test is systematic, so apply the probe to one of the terminals. Make sure you've got something to note down the readings as you go, and then we're going to put the probe on the opposite one, and there we have nothing. There's nothing coming up there at all, wouldn't expect it to. Second one in, and we've got a resistance reading 6.74 ohms. Next one, again, we would expect nothing. So we know that that middle terminal is connected to the first terminal we probed. Here we go, nothing again, open circuit. Nothing again, open circuit. This one should be, there we go, 6.73, so pretty good, pretty similar to the other one. Finally, the last one, going the opposite way this time, nothing from there, nothing from there, and the last one, no, there we go, let the needle swing, 6.7. So we're really, certainly within 10%. So by systematically measuring the resistance across all the terminals, we've actually been able to map the individual terminals which correspond to the ends of the windings. At this particular motor, they've been kind enough to colour code, so we can see the two red terminals here have a resistance, again 6.7-ish. The black terminals, we can see one black wire there, the other one is a little bit hidden, but just make it out under there going into its connection, and we can measure across those, and that gives us the same reading, 6.71, and the red terminals the same. And actually you can just see underneath there is some labelling too. So we've successfully completed our resistance checks. We know that they're all within specification, so we can move on and test the insulation. Here we're going to be testing between earth and each winding, U1, V1 and W1. So we're now going to set the meter to 500 volts. Remember, this is a 415 volt motor, so we need to be testing it with a higher voltage. Before you start, just check it for 0, and then once we're happy that the meter is operating, we can go in and test. So find a suitable earthing point, ideally the earthing screw that we have there. We know there's no paint in the way, and then we can apply it to the first of our windings, so winding U. Press and hold the meter. Sometimes the needle swings, you need to let the needle settle. And we've got in excess of 1000 mega ohms. That's a good reading. Move on to the next one. You need to apply firm pressure to cut through any grease or varnish. And again, in excess 1000 mega ohms. And the last one, press and hold over 1000 mega ohms. Perfect. Now we'll test the insulation between the windings. So between U and V, V and W, W and U. This will tell if the insulation is breaking down between the individual windings, allowing for current leakage. So leaving the meter on exactly the same settings, applying the probes again. In this instance we're using the front and back, it doesn't matter as long as you're going between windings. And there we have greater than 1000 mega ohms. Scanning through all of them, and that's the correct winding, so that's showing continuity we would expect, because that's the two ends of the windings. Here we should see a high resistance. Make sure they're on there. Apply quite a lot of pressure. It's often best avoiding the screws themselves, they can have some inherent resistance. Yeah, greater than 1000 mega ohms. Move to the second winding. Greater than 1000 mega ohms. You should see the same result from this one. Keep your finger on the button. Yep, and this last one along here we should see as as 0, because that's the other end of the winding. Again, greater than 1000 mega ohms. Greater than 1000 mega ohms. And this should be the other end of the W winding, which should give us 0. So we have a fully tested motor, and that one would be perfectly good enough to put back into service to continue its work. Thanks for watching.